And the last few presentations today will be in very close. Well, the previous ones have been very close to technical matters, but now Victor Nikolaevich will tell us about cloud computing and photogrammetry. Good afternoon, dear colleagues. I know I'm a bit of a nuisance now, but this presentation was supposed to have been delivered by the scientific director of Racurs, so I'm here to save face, so to speak, of the company. I will speak in lieu of Mr. Sechin. So now, as we live in the world of computers, when they say cloud, they mean computing or cloud computing through internet. We're going to focus on cloud computing. That's the internet life. Why clouds have become so interesting? Not every company can afford to have large clustered computers. Not each company can afford to save terabytes of data storage. So the dilemma is to buy computers, more computers, or to turn to clouds. And living in clouds has become very favorable and profitable for a lot of companies. What is a cloud? Back in the day, when IT specialists identified internet, they drew this picture. So this is one of the theories as to where the word cloud in relation to internet has come from. Another other theories suggest that a cloud is transparent, and you are not even sure how distributed computing is taking place. This is not your computer. This is a computer far, far away, and you have no access to it. In cloud computing, there is a variety of clouds: storage cloud, computing cloud, and big data cloud. Why do they distinguish between three clouds? And why is there a need to have a big data cloud as a standalone cloud? It's just that there is a totally different structure that is called for. You need to have parallel distributed computation and your own algorithm to handle big data. Speaking of modern photogrammetry, there is a lot of big data there now. Modern projects involve hundreds of thousands of images. As we look into future, we might cross the threshold and start dealing with really immense data sets. Photogrammetry requires cloud solutions that have become very popular. There are operations that are made in fully automatic mode, as measuring tie points and triangulation. These are automatic processes. Creating digital surface models, including dense ones. Orthomosaic creation, good, smoothed out, with the color adjustment, noiseless ones. All these processes are automated, but they involve. They're very good for natural parallelization. at a stereo pair level. Photogrammetry helps us a lot here. So these processes are best be moved to an external computing cloud. But still manual interference is going to remain, and we need to think of how we can work with clouds involving such manipulations. Now let's go back to our clouds. I think, and I'm sure that with your smartphones and other gadgets, you don't even think that when you took a picture, you will see that picture soon in your tablet or even on your PC. So you exchange data via clouds. We are familiar with Dropbox, one of the older solutions. Microsoft offered its own specialized solution. Apple has its cloud. Yandex and Mail.ru provide storage capabilities, and this is used to transfer data, information, pictures, and naturally these channels can be used for storing photogrammetric data. To properly organize the exchange process, a special term is used, REST API. It's a special app that makes it possible to interface and connect with clouds and hook up with clouds. So REST API is a fairly old means, and you have to adapt or customize it a lot. Also, there is the WebDev protocol to interact with clouds. Speaking of clouds and photogrammetry, we need to remember that photogrammetry often requires information protection, information security. This could be commercially viable or even confidential, secret information. Therefore, many companies create their own clouds. These are they use specialized software. So working with confidential data and ensuring protection of information becomes the order of the day. Now let's talk about speeds involved. We tested different clouds, and we found out an evident result, it would seem, but still very important. Dropbox has been tested. We put 1 GB file of information in it and downloaded it through British servers, through Khabarovsk server, through Moscow server, and we obtained varying speeds reaching 100 differences. Meaning, if we want to deal with the regular photogrammetric data, it may require a couple of hours or a month to upload. So it's important to take into account the geography and the speed of upload. Now let's go back to computing clouds. We've discussed storage clouds. So computing clouds are there to process our data on externally. So there is Microsoft Cloud, DigitalOcean. The most popular computing cloud is Amazon's, which we tested too. And in Russia, the most noted processing center are clouds created by Rostelecom. We tested them heavily, and I'll share the results of that testing with you. Data providers set up their own computing clouds. For example, Digital Globe created a cloud for computing on their computing machines. There is also Earth Observation Cloud based in Munich, which already contains a lot of remote sensing data. You can log into that, and Photomod has entered that cloud too. So you can use internationally available photogrammetric data for your purposes through that cloud. Some of the outcomes of computing effort. In Amazon, we created a virtual computer in Amazon Cloud. These are the characteristics. Fairly good. 40-core computer, 60 gigabyte of RAM, and we loaded a typical photogrammetric module with Photomod. Photomod did extraordinarily well on external computers. So with Amazon Cloud, we have been able to obtain good results. Unfortunately, using this cloud for real work is challenging because of speed limitations. So it's good in general, but if you have connectivity issues, and mostly that applies to upload speeds, I don't think that Amazon's cloud is perfect, especially those who live in Russia. Also, we tested a cloud in Munich. We uploaded Photomod there. We processed data with it. No issues arose whatsoever. Maybe there were some nuances, as it is one of few clouds allowing you to use your own software through internet browser. We couldn't test Digital Globe's cloud, unfortunately, as you have to develop a special interface, and REST API is not supported by Photomod. It's unlikely that we're going to use Digital Globe's cloud. In fact, Digital Globe wants to use Digital Globe's software to work on its cloud. So commercially speaking, this is not the best way to go for us. We tested a special virtual computer under Rostelecom. If you look at specs of that computer, they are outstanding. About 200 cores. That's a serious cluster. And I think you'll have to invest about $1 million to have it in-house, we've been afforded a lot of RAM, and we agreed with Rostelecom that we were going to try storing different ways of data storage with the different disk rotation speeds. And also we'll work on SSD, solid state disks. So we loaded 1.5 terabyte of data in 7.5 hours, so it's a fairly good speed. And if a large project is on agenda, you will save a lot of time and money. We were looking at how well PhotoMod will feel and be accommodated in that cloud, what bottlenecks are there, and if parallelization is possible. Of course, we used those processes that take the longest in photogrammetric processing, that is arrow triangulation, measurement of type points, creation of dense DSMs. This is auto-retification and creation of orthophoto mosaic. These are the most time-consuming processes. And we received the result that satisfied us all. Parallelization has been 100%, 80 to 100%, with involvement of all 160 cores. So parallelization has been very effective in terms of fortification. A lot of data is needed in terms of storage. So the speed and pressure on processors depended on how well it communicated with hard disks.
And we found out that with low speeds of HDR processors are not fully loaded, in other words, we were not efficiently using the computation powers. This full loading of processors, and that's why when we build such virtual clouds or virtual computers, we need to use SSD disks. I repeat once again, the photogrammetric companies who don't want to spend millions of dollars on own computation powers, but need to do all sorts of projects, the use of cloud technologies proved to be a saving grace. The problem that we need to address in photogrammetry is the use of clouds. I reminded you already that often we need to use stereo mode to control for the results and to build ground control points, stereo mode, and for stereo vectorization. And in this case, we would like a potential user wouldn't want to buy PhotoMod. It would be great, of course, for us to buy PhotoMod in great numbers, but unfortunately, the problem with users is that they don't always want to spend their money on our products. Still, we're doing everything possible. Now we are thinking about building up a client-server work with the cloud, and then as thin client mode, we will be able to stereo vectorize it on the own computer of the user without the need to buy it for stereo vectorization. Perhaps another important thing is that sometimes the computation clouds and the clouds for storage can be distributed or separated, and I have 2 minutes left, right? Yes. And then the support of communication between the computation and the clouds for storage require its own solutions. Cloud solutions are developing quite fast. Most recently, as you might have noticed from this slide, you can see that Amazon turnover is 8 billion already, and in a year's time it has increased by almost 70%. In Russia, the use of cloud technologies is growing very fast, and in a year's time they have shown a 40% growth of work with the clouds, and in the next few years we expect 3x or even greater growth of work with clouds. Also, from here you can see how actively you can use new services when working with different programs. When a person does, or a user doesn't buy software, but rather uses the software which can be stored in the cloud, the so-called soft ISO service. Or the user can use fully the computation and software service, the so-called infrastructure ISO service. So this is the approach to work with the clouds. I'd like to make the following conclusions: that the cloud technologies can be successfully used for the processing, and that's what we're moving towards, and the Photomod is efficient to work within clouds. Clouds can provide huge financial advantages, especially the ones that I mentioned, when you don't need to buy very expensive computation power for the company, but at the same time we shouldn't forget that we have to pay for the use of clouds, and especially the computing clouds and the storage clouds. They're not for free, but still here we can optimize the price. Very efficient in photogrammetry to work with clouds, where we store the remote sensing data. Virtually all suppliers of space imagery create clouds where their information is already stored, and I think we'll work with those companies. Also in live clouds, they have this information adopted for Photomod. And also possibly photogrammetry is switching to new types of services. Here we might mention Pixel 4D, one of the first companies which start to live in the cloud and start to provide the opportunity to work with its data in the cloud, although they're not so successful in their business, as they started to sell photogrammetric systems as a form of a box, black box, selling the full system. Still, looking at the possibility of viewing the clouds of all software as a service by supplying the full infrastructure is still quite a promising direction when working with big data in our photogrammetric work, to save money and to ensure capability for larger projects. In conclusion, I would like to say that we have big projects with our joint partners to build a huge cloud in Russia with huge computation performance to process and store information and make it open for potential users. It would largely resolve problems in Russian cartography. It will be open for our partners too, also partners from former Soviet countries, countries of the Soviet Union, because it will ensure implementation of large projects based on the use of available computation capacities. Thank you. Questions? Dr. Reisman, you have questions? Vision Map, Yuri Reisman. I'm happy, was happy to hear your presentation. I have a few questions. There are questions related to the non-disclosure or secrecy of data. I've also analyzed this field. I've checked how it works in China, for instance. If we take China and Russia, then the data security situation is more or less the same. I don't know where it is stricter, but the result is the same. So these clouds have been built or established by private companies. Indeed, looks like they're working well, but really they couldn't break down that security barrier. In other words, at the moment, these clouds provide services mostly to universities, students, to open organizations, in other words, who are permitted to do that. Others, people who are prohibited to do that, they cannot use it or won't use it, and this cloud is sitting within the country, just like what you're saying. That's one problem. Second problem about the average evaluation. Of course, it can change the pricing. How are you going to price that process? Whether the user is going to pay for per hour or subscription for a year, or monthly subscription, weekly subscription. What is the expected price? Like Photomod is $15,000, for instance, if you buy the whole package, right? But if you don't buy it by user through cloud, then how much? What will it be like? Very good question, very practical question. First thing, everybody's thinking about the secrecy of photogrammetry, right? First thing, fortunately, not all projects are secret. In Russia, for instance, the internal projects are usually secret, but when you do projects abroad, often the data are not secret, especially if you process space imagery data. Also, the closed cloud with closed protocol and closed certification. This cloud is stored in an organization. If we take the largest producer in Russia, which is a group of companies, Rostelecom, and theoretically, the following solution is possible. When we create a cloud, which is controlled in terms of processing and by specific agencies, and the use of close sharing protocol. And these protocols have already been created by the Ministry of Defense of Russia, who have their own intranet, where companies work within this intranet, and this intranet is certified and closed. This is related to security issues. Now about the pricing. Again, different solutions are possible here. First, it's a commercial market. Secondly, it's a market related to the state projects, and of course the pricing is an important issue, but each project needs to be evaluated separately. For instance, if we're talking about a professional photogrammetric company who do small, medium-sized projects, then we need to look at the production line, what projects you do, and what is more profitable for you to buy Photomod or use clouds instead. If we speak about companies who want to have a small project and have one program developer, maybe it's better to do it in the cloud. So economy-wise, we always calculated that for an average or medium-sized projects, Photomod can, if you buy the full license, you can pay it back in one project only. But everything hinges on what size the project is, and you have to calculate everything. There are no end solutions here. Zenia Vyacheslav, Center of Information Technologies. You have partially answered my question about the pricing already, but could you specify one thing? The way I see it, not all projects, especially if users are not highly qualified, sometimes you have to redo the projects with the same data. That is why the data transition and constant use of cloud systems of computation resources requires additional costs. So price-wise, maybe we can offer some kind of flexible system, because even for one project, then it turns out to be more profitable to buy a Photomod license. Yes, we have to calculate each particular case, but photogrammetry wise, when you need to do some kind of project, and when you need to develop a map of certain resolution or certain scale, usually it's a one-off project. You prepare maps, and then there is no monitoring for it, and this project will be for the same area, and with time, with certain time of updating of the cartographic information and accepted for different areas and countries. The world is not perfect. On a huge territory of Russia, 17 million square kilometers, we cannot afford to update maps once every 2-3 years like some countries do, like Israel, for instance. They can do this. Italy have much more frequent remapping time, and I'm not saying that the whole photogrammetry will go into cloud. We're just saying that there is yet another option And of course, if you have a huge production company, it's better to have all the capacities in-house, like our companies from Roscosmos do. Tomorrow you will hear a presentation from our representative of one of the companies of Roscosmos, who will tell you how they use photogrammetry, how they build huge computation capacities there. And they did the right decision made the right decision because they knew that they will have a lot of projects, but everything requires calculation. How much will be spent on photo mod, on specialists, on wages and salaries. On the other hand, money-wise, I think the important factor is that photogrammetry now requires huge computation power because it has become automatic and projects are huge. In this case, when our colleague from Ural Geoform said they used one single computer and had to work for many hours. So if they did the same thing in cloud with parallel processing, maybe they would have different optimization. But it needs to be calculated. Thank you. Dear colleagues, as soon as we are a bit lagging behind, I suggest that we postpone all the questions on this very interesting subject matter to roundtable discussion, where we'll discuss future ways of development of cartography